Okay, so I think now you are thorough with PDNF and PCNF. The next is rules of inference and formal proofs. That is, so what is the purpose of logic? What is the purpose? So why we started logic? That comes here actually. So any real life can be formulated into a mathematical problem, and using the rules of inference from the logical theory, we can come to a conclusion. There may be a set of statements. What you can do, you can write them in mathematical formulation. You can do a mathematical formulation of all the statements. Conclusion. For that, you have to use some rules which are already defined. That rules you can use and come to a conclusion. Right? See, that's what proofs in mathematics are valid arguments that establish the truth of the mathematical statements. Okay. So what do you mean by an argument? It has a sequence of statements, right? So whenever you have a sequence of statements, it should always have a conclusion, right? Okay. So the argument will be valid only if you are able to come to that conclusion. Sometimes what may happen is you may have a set of statements. Those set of statements may be invalid. It will lead to a contradiction. All those statements together, you will get a contradiction. That is, they are not consistent. Suppose some 5 statements are there. 5 logical statements you have. So combining them, if you are trying to come to a conclusion, you won't get a conclusion, because all those statements together, it is invalid. Okay, that is what they are not consistent. We say inconsistent statements, right? If the statements are consistent, then you will come to a valid conclusion. Say, for example, valid arguments using propositional logic. For example, you have a statement. If the professor offers chocolate for an answer, you answer the professor's question. Right? So if then the professor offers chocolate for an answer. So whenever this is also true, that is, these two statements are true. I am assuming that this is true, this is also true. That is, what is this statement is true now. What is the meaning of this? Whenever the professor offers, whenever you answer the professor's question, professor will offer you a chocolate, right? Professor offers chocolate for an answer. Oh no, I'm saying wrong. The statement should be changed this way. If the professor is ready to offer a chocolate for your answer, then you will answer the question. That is the correct way, right? If P, then Q. And the professor offers a chocolate. So what is the conclusion that you should expect? You answer the professor's question, right? Okay, that's what, see. This statement can be written as P tends to Q. What is P? Professor offers chocolate for an answer. That's what given here. And Q is you are answering the professor's question. So this entire statement can be written as P tends to Q. And what is this statement? It is P. P is true, P tends to Q, Q is true. Now then the answer should be Q is true. Okay, I'll prove this in another way. P tends to Q is true. Sorry. P tends to Q is true, P is true. So what is P tends to Q actually? Not P or Q, comma P. So what is the meaning of not P or Q? What is the meaning of not P or Q?
P tends to Q.
What is the meaning? That's why I derived P and Q. So what is the meaning of not P or Q? Either P is not true or Q is true. That is the meaning. So along with that I am giving no, P is true. So if you combine, what should be your conclusion? See, among these two things, either one is true, right? Or both can be true. But I am saying one of them is not true. That is, this is not true. Only if this is not true, you will get P, right? So if this is not true, then which should be true? But this statement is true. A or B is true whenever one of the statement is true. So I am giving A or B is true, but I am saying A is not true. So what should be the conclusion?
B should be true.
B should be true. So same way, not P or Q is true. Okay, P is true. Not P or Q, I am saying not P is not true. That is P is true, yeah, because of that. So which should be true now? Conclusion.
Q should be true.
Q should be true. So that's the thing. P tends to Q, comma P always imply Q. There is a name for this rule actually. But anyway, logically to convince ourselves, we are seeing this. So, okay. So, as I said, what do you mean by an argument? In propositional logic, there are two types of logic here, either propositional logic or predicate logic. Predicate logic, that's in module 2. Predicate logic means what? We always speak about quantifiers. We speak about one person. We speak about all the students. Something like that we speak. We never point out a particular person in predicate logic. We say there exists somebody. All the people in the class. Like that, we quantify the people, we quantify the things always. But here in propositional logic, we are not quantifying, we are particularly pointing out somebody, right? So in an argument in a propositional logic is a sequence of propositions. For example, you can have like this. See, I have some 5 statements together or some n statements together. All these statements, if they are valid, it should go to a conclusion C. If they are not valid, we say these statements are inconsistent statement. They are not going to give you a meaning, right? Okay. So that's what the final proposition, which is going to, which you are going to conclude is called the conclusion of this, right? So an argument is valid if truth of all its premises implies the conclusion is true. That means what? Whenever all these statements are true, if this is true, then I can say this statement is valid. Now we have seen one statement, right? P, comma, P tends to Q. It always leads to the conclusion Q. If this is true, then I say this argument is valid. Actually, that argument is valid because we have checked it. Okay. So please listen. We'll try to understand. These are all the rules that we are going to take whenever we are going to consider certain statements and prove that they are true or not. Listen carefully. See, P tends to Q. Just now I told you, right? Whenever P is true, P tends to Q is true. There comes a valid conclusion Q. And what is this rule called? This rule is called modus ponens. Mode that affirms that and all not needed. Just study modus ponens. Alright? Even if you are not able to point out what is that rule, just say modus ponens, or you can even write this. P comma P tends to Q always tends to Q. Right? Okay. Then what does this rule say? P tends to Q is true and Q is not true. Simple, yeah, you go to the truth table of this. Okay. So P tends to Q is true. Where and all P tends to Q is true? Here, here, here. And Q is not true. Among this, where Q is not true? Here, both. In both the cases, illa. I'm sorry, only this case, right? Sorry. Among this, where Q is not true, only here, this part. Okay, so that implies P is not true. That is the meaning. P tends to Q is true. Q is not true implies P is not true. Okay. Similarly, you can argue for the first statement also. P tends to Q is true. Okay, 1 minute. I'll rewrite this. P comma P tends to Q. That is, P tends to Q is true. It is true in all these three cases. P is true. Among this, where P is true? Three cases, P tends to Q is true, yeah? In this particularly where P is true. Are you all listening? Hello?
First case, ma'am.
First case. So only in this case. In this case, if you look into the value of Q, what is that? Q is true. So that's what P comma P tends to Q implies, always Q is true. Q is true here. Right? And this is called modus ponens. And here what we said? P tends to Q comma not Q. Implies the only conclusion is P is not true. This is called modus tollens. Modus tollens. Okay, then P tends to Q, comma Q tends to R, implies P tends to R. What is the meaning of this? Whenever P is true, Q is true. And whenever Q is true, R is true. So I can conclude that whenever P is true, R is true. Okay? Hello? So even this you can use truth table and try to understand. 1 minute. You can use this result for granted, but try to understand. You are using some rule now. How you have got that rule that you should understand it. We'll make a truth table and try to understand it. Third one. Oh, PQR na you need 8 rows. 1 minute. So P tends to Q, Q tends to R. I'll write P tends to Q and Q tends to R. Okay. Tell me what is P tends to Q? Here it should not be true. Here it should not be true. So true, true, false, false, true, 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 true. Q tends to R, it should not be true. True, false, second row. True, 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 false, true, true. So if you find the AND between them, true, false, 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 true, false, true, true. How can you conclude that P tends to R is true from this? Whenever P is true, Q is true, you have to conclude. Just to see here, where and all, you can see the truth values. 4 truth values are true, right? So again that go and see. Against that see, P is true and Q is true. And here also, here P is true, Q is true cannot happen. Only one line. P is true, Q is true. Got it? Or you can prove like this. Find P tends to R. What is P tends to R? Can you see? True, false, then true, 11. P tends to R true, then false, fourth one, fifth one, true. All other things are true, I think. Correct? Have I written correctly? True, false, true, P and R you check. Here it is false, then fourth one also false. Okay. Okay, ma'am, correct. P tends to R. So, what you have to do is, you have to find, when will you say that one imply other? Suppose if I call this as A and if I say this is B, when will you say A implies other? Whenever A tends to B should be a tautology, right? So check A tends to be true. That is A tends to be means what? You know, right, how to find the truth table. That is true. True. You should not find here true and here false. There is no such case. That means all the truth values are true. That means this implies this. A, this is a tautology. That is P tends to Q and Q tends to R. Tends to P tends to R is a tautology. Or P tends to Q and Q tends to R implies P tends to R. Okay. These are all just for convincing. Don't go much deeper into this. You can take this for granted, right? And this is called hypothetical syllogism. This particular thing is called hypothetical syllogism, right? Then see this. This I think we have seen this already. PRQ, comma not P. PRQ, comma not P. I said already in the first statement, right? To understand that, I told you this. PRQ is true. PRQ is true means what? Either P is true. When this statement PRQ is true, whenever P is true, RQ is true, or both true. In all the three cases, the statement PRQ is true. Right? Now I'm saying not P. That is, P is not true. So what should be the conclusion? A statement PRQ is Q is true. And this way of arguing, this way of concluding something, this is called disjunctive syllogism. Because you are using a disjunction, right? Disjunction, it's called disjunctive syllogism. So remember, many things we have seen. P, comma P tends to Q implies Q. This is called modus ponens. Then P tends to Q, comma not Q implies not P. This is called modus tollens. This you can write in any order. Even you can write P tends to Q, comma P also, no problem. Then P tends to Q, comma Q tends to R implies P tends to R. This is called hypothetical syllogism. Then PRQ, comma not P implies not Q. Or even you can write this as PRQ, comma not Q implies not P. Both are called disjunctive syllogism. These are all certain rules of inference that we are going to form, that we are going to use. We are trying to prove something. These rules one will write. Say what is modus ponens? Understood that you are all sleeping. Hello?
Like the formula from the previous one only.
What do you mean by modus ponens? So far I taught you nearly 10 minutes, 20 minutes I talked something. Okay. So tell me what do you mean by modus ponens?
P comma P tends to Q.
Okay. P comma P tends to Q.
Implies
should lead
Q.
to the conclusion Q. Huh?
Not P.
Not P. Okay. Then hypothetical syllogism.
P tends to Q. Q tends to R. It means P tends to R.
Okay. Then what is disjunctive syllogism?
P or Q And not P. It means Q.
Or even you can write PRQ, comma, not Q implies P. Both ways you can argue. Both mean one and the same, right? So after all naming, so you can name in any way. Right, next time. One more thing I'll say, this is called addition. P implies PRQ. Can you say whether this is true? What is the meaning of this? Please try to explain me. What is the meaning of P implies PRQ?
It likes
No.
PRQ is PRQ is true whenever P is true.
PRQ is true whenever P is true. Why?
It's like whenever we'll get P true, then P or Q has to be true.
Has to be true. So you have to start like this. A statement P or Q to be true, we need at least one, either P or Q to be true. So already they are giving P is true. So that implies P or Q is true. So this is called addition. You are adding something, right? More. Similarly, Q implies P or Q also I can say. Okay? And this is called, I think, simplification. P and Q implies P is true. P and Q implies Q is true. P and Q implies P, P and Q implies Q. So it's very obvious, right? P and Q, now what is the meaning? P is also true, Q is also true. So that means P is true. P and Q implies Q. It's very obvious because a statement P and Q is true only when both P and Q are true. Check. That's what, yeah, we saw everything. This is resolution. Can you understand this? What is the meaning of this? PRQ, comma, not PRR. This implies QRR. What you can use here? What is the meaning of this actually? This is also true, this is also true. I'll write this as PRQ and not PRR. That means, can you use distributive law here? The left side of the distributive law. Something like that you can use here. Or can you expand? What law? Distributive law you cannot use because all the four terms are different. Can you simplify this in some way so that you can get QRR? Or any other thing you can use? Think about it a little bit. Now think about it, yeah. Use all the laws. So say how to get QRR. QRR, no, it is meaning not Q tends to RR. Remember all these things. See, P tends to Q can be written as not PRQ. Okay. PRQ, no, so meaning is not P tends to Q. All these things you remember and just think about it. How to prove this? You can take it for granted while you are proving. Call this as a resolution and use it. But anyway, we should understand, right, how you got this rule. You should try to convince yourself why this is true. Think about it. Why are you all sleeping?
No, ma'am.
No. Then say something here. Okay, I'll write this as P tends to R. Correct? Not P or R is P tends to R. I can write this as not Q tends to P, correct? P or Q can be written as Q or P, correct? Or it is not of not Q or P, correct?
Yes, ma'am.
So what do you mean by not of not Q or P? Not P or Q, no, P tends to Q. So not of not Q or P, no, it is not Q tends to P then. Yes? Check 1 minute. I'll write again and see. P or Q, comma, not P or R. We want to prove this, right? I'm taking this. This is equivalent to P tends to R. Are you convinced with this?
Yes, ma'am.
Yes, ma'am.
So hereafter I'm going to have something. So if you are not answering, so I'll find somebody, check how many are there first. 69. One person is always absent. P tends to R. So now take this P or Q. I'll write this as Q or P. I'll write this as not of not Q or P. So till here, do you have any doubt? Can you understand this, what I'm doing? I'm trying to use hypothetical syllogism. What is hypothetical syllogism? A tends to B, comma B tends to C implies A tends to C.
To C.
That I want to use. Okay, so I got something here. I'm trying to bring this in some other format. So this implies not Q tends to P. Can you understand? Please try to understand. For both the statements, I brought some new things now. Clear?
Yes, ma'am.
Check. So,
Ma'am,
P or Q can
shouldn't
be
be the whole
yes.
thing.
Ma'am,
Ma'am, that negation sign should be for whole Q tends to P or only for Q.
only for Q.
Okay, ma'am.
Just remember. See, what do you mean by P tends to Q? Not P or Q.
Or
Okay. So,
okay.
got it. So, not of something or something. So, not Q tends to P. So, now I'll take this. I'll write not Q tends to P. And instead of not P or R, I'll write P tends to R. So, can you conclude something from this? This is like
Not
A
Q
tends
tends
to
to
P.
R.
Not Q tends to R. So what is not Q tends to R in the other way?
Q or R.
Q or R. That is the thing we need to prove, right? This is called resolution. So you need not prove this everything, but try to understand. Whenever you are talking something logically, you should try to understand what is given actually, right? Okay. It's called resolution. Okay, all these things are again stories. Can you take down all these statements? It is not sunny this afternoon, right? And it is colder than yesterday, right? We will go swimming only if it is sunny. If we do not go swimming, then we'll take a canoe trip. If we take a canoe trip, then we'll be home by sunset. The thing is, we have a set of 4 statements. All these 4 statements, you have to write it in symbolical form, and you are trying to come to a conclusion. Conclusion is, reading all these statements, I understand that we'll be home by the sunset. all these statements leads to be the conclusion, will be home by the sunset. We need to check whether whatever they have given is correct or not. So if you are very good enough in logical reasoning, reading all these 4 statements, you can argue and give a valid thing and conclude that this is true. If you are not able to do that, you are going to use the rules of inference. We are going to write all these statements symbolically. Then we are trying to prove this. Okay, how to do this? What are all the statements we need first? Preliminary statements we need, right? It is not sunny this afternoon. You can take that as P. It is colder than yesterday. You can take that as Q. 1 minute. Okay, let this be P, Q. This part alone. We will go swimming. That is be R. If it is sunny, already it is given. It is not sunny, you have given, right? You can make use of that. Okay, 1 minute. I'll write. P denotes. Shall I write it is sunny or it is not sunny?
It is sunny.
I think if it's sunny would be better, yeah.
It is sunny will be better. It is sunny this afternoon. It's up to us. Whatever we formulate accordingly, anyway, the final conclusion is not going to change. And Q, these are all called the atomic statements. These are all called atomic statements, right? So this first statement is obtained by using 2 atomic statements, right? The second atomic statement is it is colder than yesterday. It is colder than yesterday. Okay, what is the third statement? Atomic statement if you have. We go for swimming or we do not go for swimming. Which one we can take?
We go for swimming.
We go for swimming. All positive, right? Okay, we go for swimming. Yes.
Canoe trip.
We will take a canoe trip. What is the meaning of that?
Canoe is a small boat, no?
Canoe is a small boat. Good. Okay. Then one more statement, atomic statement we can see. What is that statement?
We will be home by sunset.
We'll be home by sunset. We'll reach home by sunset or we'll be home by sunset. Okay. Can you use all these symbolical notation? Can you write all these 4 statements? So I have given some symbolical notations for the atomic statements. You have to make use of this and try to write all the 4 statements given above. First statement. It is not sunny this afternoon and it is colder than yesterday. So we have taken it is sunny this afternoon as P. So here it is not sunny this afternoon. So how to write this statement? This is not P and it is colder than yesterday is Q. So this statement can be written as not P and Q. Is it correct?
Yes, ma'am.
Yes, ma'am.
Okay. So can you write the second statement? Use these atomic statements and write. We will go for swimming only if it is sunny.
P tends to R.
Inama?
P tends to R.
P tends to R.
R.
So you should read this statement this way. If it is sunny, then we'll go for swimming. That is the correct way of reading the statement so that you can symbolize it. So if it is sunny, then comma, we'll go for swimming. If it is sunny, is P. If it is sunny, we have used P, right? We'll go for swimming is R. So P tends to R. Good. Then for this particular statement.
Not R tends to S.
Okay. So others also. If we do not go for swimming is R. So if we do not go for swimming, not R. If this happens, then we'll take a canoe trip. Canoe trip is yes. So not R tends to yes. Then if we take a canoe trip, yes, ma'am.
S tends to T.
Yes tends to T. So the given statements can be written this way. Not P and Q, comma, P tends to R, comma, not or tends to yes, comma, yes tends to T. So total how many? 1, 2, 3, 4, all 4 statements. And what is the conclusion? It leads to the conclusion we'll be home by sunset. We should get T. What you have to do is you have to use all these statements. You can use all the rules of inference. What are all the rules of inference we have learned so far? Modus ponens, modus tollens, resolution, simplification, hypothetical syllogism, disjunctive syllogism. All these things you can use and try to come to this conclusion. Okay, so please take down all these statements. We'll do this. Not P and Q. I'll take one more empty slide. Not P and Q. Given, see, these statements we call it as premises. What are all the given statement? We call premises. First one, not P and Q. Then P tends to R, not R tends to S. I think then S tends to T. Conclusion. Okay. We'll do this slowly. We have to try to understand this first, then we'll do it.
Can you show the previous slide once?
One.
Thank you, ma'am.
Serial number, premises, then what rule I'm going to use. Every time I'll use some rule and come to a conclusion, right? So first one, which among these 4, which one first we can use?
Last 2.
Last 2 shall we use? Okay. So I'll introduce this premise first. So whenever you are introducing something, that is called rule P. Don't worry, all these things are just naming purpose, rule P, right? You are introducing something. Second one, I'm introducing something. So I'm introducing something, right? So now third one, from these 2 things, I'm going to conclude something. What is the conclusion? What rule you can use here?
Not R tends to T.
Very good. Not R tends to T. Yes. What rule you have used? Can you say? Nama, what is this? It is something like P tends to
Hypothetical
syllogism.
Hypothetical syllogism. I'll write rule T. Rule T, you are deriving something from the given premises. Don't worry, this you will come to understand as we do more problems. Rule T. And what is that rule that we have used is hypothetical syllogism. Hypothetical syllogism. Okay, so we have used.
Ma'am, how is the naming done? The rule P and rule T?
Rule P, nothing here. We are introducing something new. The premises you are introducing in the proof.
So
Rule
what
T,
is rule T?
from the premises you are deriving something. Then you name that as rule T. These are all just a conventional way of doing. Finally, our aim is to come to the conclusion. We have to use all these rules. That's all. This you will come to understand while we are doing more problems. Please wait. Okay. So I have used these 2 things now. So what is left over now? These 2 are left over. Something can be done. Nama, think. Finally, I need T. Think a little bit.
Ma'am, for not P or Q and Q, not P should be true,
That
right?
is correct only. That is correct. Not P and Q only. Have you written
So
anything
from there
correctly?
we can derive that not P is true.
Yes, not P is true. Will that be useful somewhere?
No, I think so.
Yes, ma'am. Ma'am, with not P, we can use a second premise P implies R, and from there we can get R, and then finally use that with not
From
R
not P.
implies T.
No.
Ma'am, we can use simplification, right? Not P and Q, so we can get not P from there.
Not P. Not P is okay. Tell me whether we have given the statements correctly. Everything is correct. Formulation is correct.
Yes.
1 minute. It is sunny this afternoon. It is colder than yesterday. 1 minute. So it is sunny and not P and Q. Then we will go, if it is sunny na P, then we'll go for swimming. R, correct. If we do not go for swimming, that is not R, then we'll take a canoe trip. Yes. Okay. Okay, everything is correct. So something it seems as if the states are not valid. It is not going to give us a valid conclusion. Check whether it is going to give a valid conclusion. 1 minute. So what you said is right. If you take not P, because not P and Q are true, not P is true. Not P is true is not going to give us anything.
And then if you not R is true, then this not R implies 2 and not R will give P.
Where is not R true? I think these statements are not valid. 1 minute here. Or I have written something wrong. Not S entity, not. Because this is not giving a valid conclusion. Somewhere something is missing. One. Sunny this afternoon and it is colder than yesterday. Not S and C. Okay. We'll go for swimming only if it is sunny. Okay.
Is it R tends to P, ma'am?
Yes,
The
yes.
second
I
state.
think that's the thing. That is the thing I'm saying. We'll go for swimming if it is sunny. Hey, I think this is wrong. They have taken it as wrong. See, we will go for swimming only if it is sunny. That means it should be here also. 1 minute. We will go for swimming only if it is sunny.
R tends to P.
It should
According to
be
what
R tends to P. 1 minute, 1 minute. There is one specification here. Simply if it is sunny, we have to formulate this in this way. If it is sunny, then we'll go for swimming. But here, we'll go for swimming only if it is sunny, means it is R tends to P. I think while we are learning this, there are many ways. 1 minute, I'll go back. Just wait for 2 minutes. Logical equivalence. I don't want this. I said I remember. Oh, it is missing here. Yeah, wait, I'll bring it. I do remember there are many ways of interpreting P tends to Q. So whenever you see only if, na, then you have to take it in the other way. The meaning changes. Maybe tomorrow I'll tell you. I had one slide explaining that. I don't know where it is not available now. Tomorrow I'll show you that. So in that you take, this should be R tends to P. 1 minute. This should be R tends to P. Okay. Say whether now something can be done. Oh, I think now it is easy. Why it is R tends to P? Because of this particular thing. We will go for swimming only if it is sunny. For this, I'll give you some explanation because I have something for you. I'm not able to find that particular slide because many things are there. How to interpret this particular statement? P tends to Q. When you can say P tends to Q. P only if Q, something like that, you have many things. Tomorrow I'll show you that. Please do remember this is always R tends to P, the other way. Right? Okay. Now from this, can you say you have used these two things? So you come to a conclusion, not R tends to T. Now you have to use these two things. As you said, introduce not P and Q. Okay, rule P. Then not P is true. This is called simplification, huh? Simplification. Then introduced R tends to P. Rule P. I'm introducing this statement. Can you combine these two things and say something? Another name is there. P tends to Q, comma not Q. What is that called?
Not R.
Tolerance, I think, ma'am.
Not.
Modus.
What is that called? Modus?
Modulus tolerance.
Modulus is modest tolerance, right? So now from 5 and 6 you will get not R, rule T. Why it is rule T? Because you are deriving something from these two. And what is the rule you are using? Modest tolerance, right? Now we are actually
I think we can use ponens, right, ma'am? Modest ponens.
tolerance.
From 3 and 7.
No, like 3 and 7, ma'am. Modest
From
ponens.
3 and 7. Okay, you will get T.
Yes, ma'am.
Modest ponens of 3 and 7. So this part alone I'll repeat once again. I'll tell you. So I'll try to find that. In what ways you will say, when you will say P tends to Q. What are all the statements can be interpreted as P tends to Q, and what are all the statements can be interpreted as Q tends to P. That I'll tell you tomorrow. So after seeing that, again we'll do this problem. I'll come with more problems. Maybe at the end of module 1, again we can have one more tutorial completely covering everything. And then we'll go to module 2. I'll stop here. See, at the end of the class,